bit. Its tips clear the lining of the case by a fraction of a millimetre, yet in flight will spin faster than the speed of sound. After 2 weeks of assembly, every completed engine is fitted with vast aerodynamic ducts and inched across to the factory's purpose-built flight test centre. Here, it'll be fired up and put through its paces in a simulation of the harshest flight conditions.
3, 2, 1.
While engineers monitor vibration, rotation speeds and temperatures to ensure everything performs perfectly.
Vibration is looking good. Max conditions now, hands down to go. 3, 2, 1, go.
Signing off newly built engines isn't all they do at the test centre. Dave Benbow is in charge of testing prototypes for new engine designs before they ever take to the sky. And that means carrying out tests that are much more challenging.
We run thousands of hours of testing. Our primary requirement is to show that the engine is safe to fly, that it's airworthy. We conduct a number of tests to do that, but really we're trying to meet the regulations of the safety agencies. This engine is a flight test engine, and in that extent it has a lot of instrumentation that production engines wouldn't have. That you can see here is led up off the engine and into the pylon so that we can record the data on the test bed when it's installed.
Testing is so exhaustive, it can take 2 years for each new design.
The cold start test is a very important test. We need to be able to start the engine under cold conditions, cold as minus 40 degrees.
Removed from its giant freezer, everything must still work perfectly when the engine is started.
We have to make sure that the gearbox will turn when we start the engine. Other tests, so water ingestion.
Water is poured in at 30,000 gallons an hour, but there must be no loss of thrust.
We have to demonstrate that the engine can cope with rain and hail ingestion, and that the compressors can cope with the amount of water going through the engine that it might get in flight, and that the compressors continue to run and that the combustion system remains stable. But one of the key safety requirements we have to ensure we meet is that in the unlikely event of the release of a fan blade, that it's contained by the fan case. Well, it's an absolutely key test in that we need to make sure that there's no chance of the fan blade escaping. On the test, there's an explosive detonation which releases the blade from the disc at max takeoff speed and fires it into the fan case. When this event happens, the energy that's generated by the blade coming off is about the equivalent of a 1-ton car being dropped off a 200-foot cliff. And the casing here then has to retain that and ensure that nothing is released outside of the fan case structure. So it's a hugely expensive test. But our commitment to safety and demonstrating requires us to take that asset and to complete that test, irrespective of what we're left with in the end. The engine is destroyed. Although it's contained the blade and run down safely, the components that are in that engine will not be used again. Effectively, that engine is then written off.
Only by sacrificing an entire engine like this can they be sure the fan case really does its job. It's 6 in the morning and the start of another shift on the assembly line for fitter Andy Taylor.
I just wait round the corner from here, so I work on where they build the stacks. Work 3 shifts, work mornings, afternoons and nights. I'm on mornings this week. Morning. That's the inspection department, very friendly people there. This is my engine for today.
Andy's task today is to fit the first of a network of sensors to the engine.
These are connected to the thermocouples, and these tell the brain of the engine that if there's an overheat problem, it'll tell it to like alter something inside the engine to cool it down, or vice versa if it's running too cold.
When it's running, these sensors will measure temperatures, pressures, speeds and vibration at critical points in the engine. The sensors constantly feed that information to the engine's own electronic management system, its brain, that ensures performance is optimised at all times. But it doesn't stop there. Data collected from every Trent engine in the air can even be transmitted via satellite back to Derby. It's received here at the factory's 24-hour monitoring station, manned by senior engineers to keep an eye on Rolls-Royce engines all over the world.
Alan, we've got an issue on engine 41992. We can just see that the exhaust temperature's just going up on that engine.
This is 21st century jet engine production, part of a high-tech support package that gives them a commercial edge over competitors.
Increasingly now, as the airline buys a Rolls-Royce engine, we secure a service package with them, sometimes for as long as 20 years, where we will provide all the maintenance, all the spare parts for their engine. We will make sure they have engines available whenever they need them to support their aircraft, and they simply pay for the number of hours they fly.
At peak times, the team may be monitoring engines carrying 400,000 passengers.
We're sort of watching in the region of 8,000 to 10,000 engines, 24/7, 365 days a year.
Well, and that's the question, is this pretty normal or is it not? We're looking at speeds, pressures, temperatures. We're just nipping problems in the bud before they happen. So people aren't waiting around in airports for the flight that's been cancelled or delayed again. So that's ultimately what we're trying to do.
The centre receives 1.5 million measurements every day, from anything up to 1,200 Trent engines at a time.
Typically a minute after the aircraft has sent that information, I can see it in graph form.
The data is analysed by computer, and if any unusual readings are detected, the engineers are automatically alerted.
Probably 95% of them we can very quickly sort of work out that there's nothing to worry about.
All the help desk engineers are experienced enough to solve any problem that might crop up.
I worked with Rolls-Royce engines hands-on, mainly in the Royal Navy for 13 years.
And they're just a phone call away from maintenance crews at key airports around the globe.
Yeah, I've just had an email if he's asking for data going back to January 2009, LP vibration data. Do you think you can answer that?
Back on the assembly line, this Trent engine has hit a problem, just 1 week away from its completion. The final module needed for the vertical stack has been held up on its way from Europe. Without it, the stack can't move along the line.
It's a turbine which actually drives the big fan at the front of the engine, which is mounted inside the fan case.
The engine is stuck in the assembly tower, but the fitters can't afford to lose any time. Instead, they've identified parts that can be fitted ahead of schedule.
It could arrive any time in the next hour, it could be in the next day, you know, we don't really know. So what we've done, we've jumped ahead and carried on building to try and get things done. As it is at the moment, we can't move it, we can't pick it up without that final module.
Any hold-up in the production process could cost money, so tracking down a replacement module is critical. And Kath Taylor is straight on the phone.
Can you guarantee that it will reach us before 6 a.m. in the morning? Yes? Yes.
At long last, it does arrive. And even though it's the middle of the night, the build will carry on. Working through the night is part of life for everyone on the production line. In Warwickshire, father and son Bob and Lee Blackwell are starting another night shift at the fan case factory.
It takes a bit of getting used to what it's like. It's quite hard. By Thursday, you're sort of ready for the weekend and catch up on your sleep. We tend to work the same shifts. On nights, we tend to get on each other's nerves. It's a testing shift, you know what I mean, when you're tired.
Tonight, they're working on a new fan case, bigger than any other, to be fitted to a new Airbus that is currently being built.
This is the biggest component that we've actually manufactured to date, 118.
We have orders for 1,000 Trent engines, and we will build that early next year. We will start testing it, and we hope to see it in the skies about 2 years from now.
But investment in new technology is worthless without investment.
Which go through the main part of the engine. These are the coverings that go around them to make sure that the parts don't become damaged. You've got the various drilling machines down here. And then as you walk through here, this is where I work. This is the shaft supports office. Like, from a young age, I was always into, like, building things and, like, designing. And then the opportunity came round of, like, me getting the young apprenticeship, and also my family. Like, my dad's an engineer, my granddad's an engineer, my uncle's an engineer, so I've had a little bit of influence as well from them. But generally, I just like engineering, and I like the fact of, like, designing and building.
I identified at an early age that, you know, he liked engineering because, you know, I think when he was about 8, I bought him a Connects, and you know, in about the space of a couple of days, he'd he'd thrown away the manual and started making models of his own.
Like every apprentice, Neeraj can expect to spend 3 years or more learning the basic skills of his trade. So having a passion for it is really important.
Today I'm trying to make one of these control rods, which, as you can see, is here. And basically it allows the pilot to control the amount of airflow that's going through the engine and change various settings in the engine of the flaps and angles. You tell somebody you're 16, you work in Rolls-Royce, it's quite they see you as in a different light, and suddenly, like, that you're actually something special and something a bit different, because it's really quite prestigious to work in such a big company like this at certainly the age that I am.
So first data image, blued out from one end to the other.
Okay.
Second data image, 90 degrees to it. Check that with an engineer's square.
Now I'm thinking, wow, what a change a couple of years can make to a life. Because going from schoolboy to engineer, it's quite a radical change, and I'm quite pleased with that change.
Once every engine is built and tested, its last stop is the customer delivery centre, where it has to pass scrutiny by engine inspector Mike Riley. It's a huge responsibility. His will be the last eyes to see inside the engine before it takes to the sky.
I've been at Rolls-Royce for 5 years now. In fact, this month. Before that, I was in the military as a helicopter technician on the first-line maintenance. I've actually wanted to work for Rolls-Royce for some time before I came to work here, and it took me 2 years of applying before I could get in. So it's not the easiest place to get into.
Mike's is one of the most specialised jobs on the assembly line. Like a doctor doing keyhole surgery, he uses a borescope to inspect the inside of the engine.
Basically, every single rotating stage within the engine we'll look at, plus the combustion chamber. Literally, the whole of the inside of the engine is borescoped. This is the first stage HP compressor. At the moment, I'm turning it rearwards. Usually the blades will come towards you. I'm just looking for any damage on the actual blade surface, leading or trailing edges. Occasionally you can get a little bit confused in there because there are so many blades. This is the first nozzle assembly that we're looking at, with all the hundreds of cooling holes on it. It's possibly the hottest part of the engine here. You know, practically a surgeon.
After Mike's final inspection, another Trent 700 engine is bagged up and ready to leave the factory. In a few days, it'll be in France and fitted to another Airbus 330 plane, just one of 300 engines built this year. These engines are Rolls-Royce's key to success, but it's keeping ahead of the competition that will secure the future for everyone in Derby. But right now, there's a big day ahead. Today, All eyes are on the performance of the Boeing Dreamliner, and of course, the Rolls-Royce engines that power it. It's a big day for the aeroplane out in Seattle, and an even bigger day for the team of engineers back in Derby, watching the preparations for the flight live online. As the aircraft prepares to take off and the engines fire up to full power, there's nothing anyone can do but wait, watch, and see what happens next.
And here she comes, the 787 Dreamliner.
Way to go, Rolls-Royce!
It's a massive coup to provide the engines for a new airliner's first flight. And it's something to be very proud of for the people who build them.
Quite an emotional moment for everybody involved, particularly for all the guys here who have built the engines, all the engineers who have designed it over the last 4, 5, 6 years. Some of these people have devoted their entire lifetime at work to this.
Ecstatic, really. Really delighted to see the aircraft take off after what's been a pretty long and tiring journey to get this far, really.
But the success of the flight can only really be gauged when orders for the new engine start coming in.
Great news. Another order for 5 Trent 1000 powered Boeing 787 aircraft were placed this morning. Particularly good because it's quite a tough market at the moment, and so it does show testament to the technology in this engine that even in this market people are still placing orders. It's a great day to be in the job. It's a great day to be in Rolls-Royce. It's a great day for Derby.
For the 11,000 employees in Derby, it's another ordinary day, with more Trent engines to build. And in Warwickshire, it's the end of another shift for Bob and Lee Blackwell. But it's also the start of a new chapter in the story of the Trent engine, because the first fan case for the next engine in the Trent family is finally ready and about to be revealed.
We've organised the corporate comms team to come down to take a team photo. So we're going to get everyone that's been involved in the project together. There you go, look at that beauty. There you go. That's it. Work of art. It's a work of art.
It's something for Mark and his team to be really proud of. And a senior project manager from Derby is on his way to see the unveiling.
Now that looks really good. It's really good. Pull it this way a little bit further, and then have those two sitting behind it. We can all gather round the front, guys. If everyone comes in round the front, gather round. We've got to get some photogenic people. Got it.
This is a major thank you to all of you, and thank you very much for the fantastic effort you put in. This is so many firsts for us as a project. It's our first module and it's our biggest module, and a major milestone for our first engine. So thank you very much. Thank you.
That's great. Well done.